Hello pre-calc friends. Today we're going to be going on in section 7.1 vectors and talking a little bit more about what we can do and what we can find out about them. But I hope so far you've been enjoying this chapter compared to the really difficult chapter 6 that we just exited. This chapter is kind of nice and very, very easy to get through. So I'm going to go forward, and we already talked about most of this stuff before, but now today we're going to talk about the direction angle of a vector. As you know, when you draw a vector, it always has two things. It has a magnitude, that's how long it is, and it has a direction. And that's all vectors are. We represent them with arrows. That's basically what they do. They have a direction and they have a magnitude. And magnitude is how long it is. Well, so far you know how to find the magnitude of a vector by doing the Pythagorean. So if we have a u vector, and we want to find the magnitude of that, you basically just do Pythagorean on its component form, and that works great. But now, how do you find the direction angle of a vector? I know by looking at this vector over here that he's pointing sort of maybe northeast, but like exactly what angle? If I was to sort of cut and paste him and put him on a coordinate plane with his tail planted at 0, 0, like what is that angle? What angle does he make with the x-axis starting from 0 degrees? That's what we're going to find out today. So anytime we put any angle on a coordinate plane, like we just did before, like say this guy here. Let's put this vector here, again with this tail sitting at 0, 0. And there's my vector u. What's the direction? Meaning, again, what is this angle theta here that it makes with the x-axis at 0 degrees? So what I'm going to do is, like we did in the past, I'm going to draw a triangle here, perpendicular to the x-axis. And then I'm going to give some components here. I'm going to say that, well, basically on the bottom, this x-coordinate is going to be basically a length of a, however long that is. And then on the right-hand side, I'm going to say that this vector goes up a component of b. So basically the sides of this triangle are a and b and the magnitude of u, whatever the length of that sort of hypotenuse is. So in order to find theta, do you recognize that if I look over here to the right-hand side, if I took the tangent of theta, that would just be the opposite side divided by the adjacent side. That's really useful because if we can break our vector down into components with a's and b's, we can use this trig to solve for theta. Now, again, our goal is to solve for theta, right? But this formula is not solved for theta. So can we take this formula and make it a little bit more useful? Let's get theta by itself. In order to do that, we need to get rid of the tangent. Did you guess tan inverse? Well done. All right, so really, here's our formula to write down, guys. To find the direction angle vector, you take the tangent inverse of the b over a. And again, b and a come from the component form of the vector, right? When we learned component form before, there's a and there's b. And that refers to, again, up here, he's a length of a and sort of a height of b, and that's what makes my final vector u, is a component of a comma b. So take the tangent inverse of b over a, and you should be in degrees right now, and you should get it. Okay, let's try a couple, guys. So burn this formula into your brain, write this in your notes, put stars next to it. It's really popular, but also really easy too. Let's try some examples. All right, number one, can we find the direction angle? So right away I'm thinking, all right, that's the tan inverse formula of the vector v, which is component form 3, 4. So that's 3 is a and b is 4. All right, well, all we got to do is plug that into our formula right up here. Let's give it a try. I'll try it down here on the bottom. Number one. All right, my angle theta should be equal to the tan inverse of b over a, which is 4 over 3. If I do the tan inverse of that, that should give me the theta angle of where he lives. Well, I'm just going to plug that right into my calculator. I'll do 4 divided by 3 and take the tan inverse of that in degree mode, and I get that's about 53.1 degrees. And that's how easy it is. But you know what? Let's just double check really quick. Does that make sense? So on another page, I'm going to come back to that. Oops, maybe not. I'll stay on the same page. Let me draw a little x-axis over here. And can we just double check? Does that make sense? Here's what I mean. We have an angle of 3, 4. If I was to graph 3, 4 on this x-axis, do you agree it'd probably be about here or so? So my vector from 0, 0 kind of looks like this. This is the vector v, which is 3, 4. Does that angle right here, does that direction angle look to be about 53.1? Yeah, I'd say so. 3, 4 would be in quadrant 1, and my angle is in quadrant 1. So it's always good to double check our quadrants. And there's number 1. Number 1 is 53.1 degrees. All right, if you want to try number 2 on your own, go ahead and pause the video and come on back. We'll check our answer. All right, welcome back. Here's number 2 now. Number 2, let's find the direction angle. So again, I'm thinking tan inverse formula of the vector u equals 3, -4. All right, here's my A, here's my B. If I take the tan inverse of B over A, that would be -4 over 3. All right, my calculator should say, how about -4 divided by 3, tan inverse? That would give me a -53.1 degrees. All right, well, the calculator gave us a good answer. The problem is direction angles can't be negative. Direction angles, I'll put this note way up here on the top. Direction angles have to be positive. And we'll see more why later, but just for the shortcut, let me just say that's positive because in real life examples, we need to always use positive angles for vectors. When we're traveling, we're always traveling in positive angles. So to use vectors, we need positive angles. Okay, so I can't take that as an answer, but let me check and see. Let me check my quadrant. If I was to actually graph that point, 3, -4 would be in quadrant 4, I think, right? Let's see, if I graph that. 3, -4 would be about here. So my vector u is here. That's great. And that's why they gave me that angle of 53.1 degrees negative. That makes sense. But I can't take that as an answer, folks. I need to make the positive version. Remember how we did that before? It's all about coterminal. So why don't we add 360 to that? And my real answer, my real coterminal for that vector should be about 306.9 degrees. That's my real direction angle for that vector. Okay, so, hey, here's a little note here we can put off to the top. When you're finding direction angle, big hint, check your quadrants, folks, to make sure that you are actually graphing the right vector and you're finding the angle of that same vector. Because we notice if it's in a different quadrant, we have to adjust our answer. For number 1, we didn't have to do that. He was in quadrant 1, so he was good to go. But in number 2, because the tan inverse gave me an angle that was negative, I had to find the positive version. Okay, there's number 2. Number 3, as I give a little hint here, is a little weird, which kind of scares me a little bit, but let's give it a try. Okay. Let me see, I need a little bit of space here. But first I'm going to do the direction angle. So I'm thinking tan inverse in my brain of this vector, w equals -1, 5. You know what, right off the bat, because I'm scared about quadrants, and I gave you that little hint, let's check our quadrant right now. Where do you think is -5 living? Did you guess quadrant 2? You're absolutely right. Okay, so when we do the tan inverse and find the theta angle for this, we might have to adjust it. All right, I need a new page. -1, 5. All right. Here we go. Let me start here. W was -1, 5. Now I want to find the direction angle. So theta equals the tan inverse of B over A. How about 5 over -1? I'm going to put that in my calculator. I'm going to get 5 divided by -1. Well, that was easy. That was -5. And how about the tan inverse of that? I get -78.7 degrees. Okay, remember we can't take a negative. We need to find the positive version. Last time we added 360, is it the same step here? Is it just that easy? Let me see. Remember how we said that -1, 5 was in quadrant 2? Let me see. If I was to graph that, -1, 5 would be about here. Do you agree? So there's my vector W. But wait a minute. The angle that the calculator gave me was -78.7. That's in quadrant 4. That kind of makes sense because if you remember when we do tan inverse, remember how we said that tan inverse only lives in quadrants 1 and 4? So we're only going to get answers from tan inverse between quadrant 1 and quadrant 4. So that's why he gave us 1 in quadrant 4. That makes sense. But that's not what we want. Our vector is really over here in quadrant 2. So now how can I get this vector that it gave me? It gave me 78.7. How can I get the actual vector back out that I really want? How do I get that? Do you have any idea? Well, there's two things we can do. If you think about it, this is basically making one straight line between the real vector w and the vector that I made over here. So would it be okay just to take our vector and add 180 to it? Yes, absolutely, we can do that. Or if you want to think about reference angles, here's another way you can think about it, folks. Let me draw this again. Here's our vector w. This is -1, 5. Remember back in chapter 6 when we would solve this, this would be the same reference angle that I had over here in quadrant 4. This is 78.7 degrees. But then we'd say that's not the real answer. We have to take it always from 0. So how do I find that? By subtracting it from 180. So two different steps. Do you want to take over here in the left drawing, do you want to take the angle that the calculator gave you and just swing it on back around to the real quadrant 2 where we need it, just add 180? Great idea. Or if you want to think back to chapter 6, what we did over here on the right-hand side is we took the vector that we really need, you moved your reference angle of what the calculator gave you over here, and then figured out from 0 what is that real answer. Either way, I'm going to take my vector answer, dangle, from the calculator and add 180. So really, the direction angle should actually be 101.3 degrees. And again, if you look at quadrant 2 and you look at vector w, that looks like it's about 101.3 degrees. Okay? So again, a big note, I'll put off to your side again. Always, folks, when you do direction angles, make sure you check your quadrants. Meaning check the quadrant of the vector you should get versus check the quadrant of the angle you got from the calculator. If they match, like you did in number 1, you are good to go. But if they don't match, figure it out. Either we had to add 360 to it or we had to add 180 to it. So use a little bit of visual help for you guys. All right, good job, guys. That's how you find the direction angle. Awesome.